The sculpted bedrock landscape of French River has long attracted attention. Sculpted forms, S-forms, have been described at many locations and attributed to glacial erosion because they were closely associated with glacial bedrock. We surveyed 16 sites. To summarize, we review 7 sites in a series of 6 videos. We see different types of rock erosion. These erosion forms occur independent of rock structure. As flow overcomes an obstacle, longitudinal features occur in the flow and in the rock erosion. Flow around obstacles initiate upflow, thus side, crescentic erosion forms, or crescentic furrows. Crescentic horseshoe vortices extend downflow as longitudinal vortices to form long furrows. The first video, Henvey Flat Island, illustrates the crescentic to longitudinal flow motif. Pairs of longitudinal furrows result in a remnant ridge or rock drumlin. Video 3 describes well this terrain at German Island Site 5. We now look at another crescentic form, a sickle form. These forms occur in clusters representing organized structure in the flow. Site 6, Outer Fox Island, illustrates sickle-shaped forms, Suchalvanen. Drones capture multi-scale erosion forms. Crescentic furrows 5 to 15 meters wide occur at high end of form scale. Video 3, German Island, illustrates the hierarchy in form scale. These eroded terrains display aspects of turbulence in separated flow. Take the example of water flow on a rise. Vortices form, in particular as transverse rollers, at breaks in slope. Fields of vortices disperse from transverse vortices at hydraulic jump. Transverse vortices, rollers, are stable at breaks in slope. These transverse rollers are well known in hydrodynamic engineering. River surfers and kayakers use these rollers. Stable horseshoe vortices form crescentic erosional furrows. Long furrows extend downflow. Flow evolves rapidly to fields of horseshoe vortices. Fields of crescentic erosion forms, Suchalvanen, result from one flow event. The end result is a field of self-organized S-forms. Forms show directional integrity and no cross-cutting fields. Now let's look at erosion process on lee side downflow. At the break, some longitudinal vortices convert to vertical vortices, eroding potholes. Video 4, Key River and Henvey Inlet, illustrates potholes formation. On lee side, plucking occurs commonly along existing joints. Video 5, Plucking Island, illustrates different type of plucking. Plucking is sometimes modified by water erosion. Video 6, Cavitation Island, illustrates the modified plucking. Video 6 also describes the small pit forms associated to S-forms and plucking. The bedrock of all the studied sites is depleted from basal sediment. From the presence of trap boulders, one can easily draw the following conclusion. Basal sediment was first washed away. Then the bedrock was sculpted with crescentic and long furrows. Subsequently, boulders were trapped in these furrows. Boulder percussion marks may be due to stuss-side collision, more likely due to bouncing along in the high-velocity flow. Another topic beyond the scope of these 6 videos is the importance of structural geology in correlation with the different types of terrain. The Grenville province is made of hard granite rocks. Still, each formation has its own resistance to erosion. Inlets and island ridges are clear examples of differential erosion. At the end, all types of rock were eroded into S-forms. The structural control at great scale is a video project outside this series. Stay tuned!